In part 4 of the Unit 2 notes, we are going to be covering the separation of mixtures. One technique that you could use to separate a mixture is filtration. Filtration is a technique used to separate a pure substance in a mixture comprised of particles large enough to be captured with a porous material. So for example, in this illustration, you can see a beaker which is filled with a liquid and an insoluble solid. So for example, this could be a mixture of sand and water. You have a funnel with some type of filter paper inside of it, and when you pour this through, the solid is going to get stuck on the filter paper, and any of the liquid can pass through into a flask. So here you're able to separate out this heterogeneous mixture. Next, you have evaporation. This is a technique used to separate out homogeneous mixtures where there is one or more dissolved solids. So in this example, we have the water which is being evaporated away, and then we have some kind of substance which is left in the end after the water has evaporated. This would be a good process to use when you have salt and water mixed together. So in the absence of the water, the salt would recrystallize, and you would be able to get that back out in the end. Next up, we have distillation. This is a technique which could be used to separate two or more pure liquids using boiling point. So in our illustration here, you can see within this distilling flask, we have multiple liquids mixed together. And let's say that they boil at different temperatures. So maybe one boils at 50 degrees Celsius, another at 75 degrees Celsius, and another at 100 degrees Celsius, just to keep the numbers nice and easy. So as you start to heat it up, you have your thermometer here, so you'll see that, okay, it hits 50 degrees Celsius, and all of a sudden you start to see these vapors come up. They're going to come up this glass, and they're going to hit cooler glass right around here. When a gas which is very hot gets cooled down, it's going to condense and go back into the liquid state. It's going to run down here through this condenser. This condenser also has cool water running around the outside of this tube, and it's going to flow into the secondary container. Now, let's say I get somewhere in between. So maybe I'm around 60, 65 degrees Celsius. You're not going to have any more liquid evaporating at that point. So you know that you've gotten all of this liquid out, all of the liquid that boiled at 50 degrees Celsius. So then you can take this flask away, put a new flask underneath, and then continue to heat up until you hit your next threshold. Then you could separate out all of the liquid that boiled at 75 degrees Celsius, put a third flask under there, and get the 100 degrees Celsius one. Now this distillation technique could also potentially be used if you have a solid dissolved within a liquid, but you want to keep the liquid in the end. So for example, on the previous slide, we were talking about salt water. We evaporate away the water, but if you wanted to potentially save that water, you could then have the water go through this condenser out to the other side. You've kept your water, and then the salt would be left behind over here in the original distilling flask, since the salt would never evaporate. Our next technique is called decanting, which is basically a fancy scientific word for pouring. So this is a technique which is used to gradually pour off a liquid without disturbing sediment. So here I have this beaker with a liquid and some kind of solid sitting on the bottom, and I am pouring it down into a secondary container. If I have a substance which is suspended within the liquid, so it's floating around, this would be a pour technique. I would likely want to use filtration instead. But if I have something which is fairly dense and sitting at the bottom of my beaker, then I could just pour off the liquid just fine. Next up, we have magnetism. So this is a technique for separating a magnetic metal from any other substance. So it's pretty self-explanatory. You've all seen magnetism in action before. And then we have a centrifuge. This is a device which can separate fluids based on density using a gravitational force. So you would have this machine with these little tubes. So you can put in your liquid, put it inside. It spins around very quickly. And any part of the liquid which is more dense is going to go down to the bottom, and any part that is less dense is going to go up to the top. This would be good for something like a blood sample, where you can separate out the plasma from other components of the blood. Next up, we have chromatography, and there are a couple of different types that we're going to talk about. In general, chromatography is a technique used to separate a mixture by passing it through a solution, suspension, or as a gas through a medium in which the components move at different rates. Essentially, what you have is one substance which is going to have varying attraction to another component, and depending on how attracted it is, it's going to move different distances. So in the example of paper chromatography, what we had here was this special type of chromatography paper, and there's a little solution which is hard to see down here below this line. So it could be water or potentially some other liquid. On the paper, you have this line here with dots of different substances that you want to test. Now, you should all know that when you put a piece of paper up against a little puddle of water, the water is going to wick through that paper, and that's what's happening here. So the liquid is going to wick up the paper, and it's going to drag along whatever substance happens to be along this line. Now, in this example, they were using different types of ink. Now, depending on how attracted each component of the ink was, it's going to go up different amount or different lengths of the paper. So you can see this one stretched out pretty nicely. We have this yellowish green component down here, but we also have this blue component at the top. So this particular ink had multiple types of ink inside of it, or multiple pigments. Over here we have an example of gas chromatography. So you have this machine with a sample injector. You inject it with your sample, and you have this carrier gas which is going to push it through this tubing. Now, depending on whether the parts of the sample are more attracted to the gas or the tubing, they're going to come out on the other side at different rates. Anything that is not attracted to the column or potentially very attracted to the gas is going to push through quickly, and it's going to pop out on the screen first. And anything that is more attracted to the column is going to take longer to get through these tubes, and it's going to come out second, third, or so on. So these are both examples of chromatography. All right, so for our checkpoint, we're given a scenario and we're going to pick out which of these techniques could potentially be used. So which of the following separation techniques could be used to separate a mixture of two liquid compounds at room temperature with a difference in boiling point? You also must retain both components. So that's important part of this. Now, it says that we have a difference in boiling point. So that means I could potentially use evaporation, because they would separate based on your boiling point, or you could also use distillation. But the fact that you have to retain both components, that means distillation is going to be the winner here, because with regular evaporation, whichever substance is going to evaporate first, that's just going out into the atmosphere, not actually capturing that in the end. So distillation would be the best technique to use there. That concludes part 4 of the Unit 2 notes. When we come back for part 5, we're going to be going through endothermic and exothermic processes and the anatomy of the periodic table.